Hello, this is Dave Neary, and welcome to the Ampere Developer Impact, where every month we're going to take a look at what's going on in the Ampere community and talk to some guests about what they've been doing and how they work with Ampere hardware. My name's Dave Neary.
And I'm Aaron Williams. In this series, we'll be focusing on bringing you interviews and discussions from the Ampere community, plus other guests we think the community will find interesting and fun. We'll start every episode of The Impact with a quick recap of what's happening in the community. Dave, why don't you start off with a recap of some of our travels?
Thanks, Aaron. And, it's been a busy period for us for events. The fall highlight for me was our trip to Chicago for KubeCon. We were also in quite a significant way at OCP Summit in San Diego. But in KubeCon in Chicago, we were sponsoring a Day Zero event, the App Developer Summit. And, oftentimes KubeCon focuses very much on the administration and running of Kubernetes clusters. And App Developer Con was really an event targeting application architects and developers. And it was a really great event to participate in.
Also at KubeCon, there were two major announcements. The first was that Oracle announced that they were donating $3 million in OCI credits in support of CNCF projects. And Dave, the second big announcement is about the project that you and our guests brought together rather quickly, and is the topic of our interview today. Why don't you tell us about this new project and introduce our guests?
That's right. So in November, we launched a pilot project with the CNCF to give CNCF projects hosted on GitHub the opportunity to use GitHub runners hosted on Equinix Metal, Arm64 runners hosted on running on Ampere servers. So this is for CNCF projects running on GitHub. A lot of them use GitHub Actions for their CI and testing. And when you're using GitHub Actions, it's actually kind of tricky to use ARM64 self-hosted runners. So what we did is we put together this pilot to give us a number of projects the opportunity to run hosted runners managed by Actuated. So it's you add one line to your CI scripts, and then you automatically have your builds running on ARM64. So today we're going to bring some of the key people who were involved in that pilot together to talk about how it's been going. So first up, Ed Vielmetti is the developer partner manager at Equinix, and he runs their open source partner program and manages the CNCF Community Infrastructure Lab, which is part of that program.
Hello, everybody. Nice to see you guys.
Next up, we're going to talk to Alex Ellis. Alex is the founder and CEO of OpenFaaS, which is the company behind Actuated, and he started the OpenFaaS project. Thanks for joining us, Alex.
Hi, everybody.
And finally, we're going to talk to Chris Aniszczyck, the CTO of the Linux Foundation, and one of the founders and architects of the CNCF, right from when it started back in 2015. Thanks for joining us.
Hey, all.
So, Chris, can I start with you? Can you describe a little bit the pilot we're running, how it came together, and why the CNCF teamed up with Ampere to support it?
Yeah, no, so, kind of great to be here in December. It's 8 years since CNCF started, and I think, we've seen an evolution, throughout the kind of history of our organization. And we've always kind of been on the bleeding edge of, trying out new CI/CD systems, new architectures, and, through our relationship with, Equinix, I think we've had this, we call it the Community Infrastructure Lab that we've had around since 2017, if my memory is correct. But, in those days, for CNCF projects to, really take advantage of, bare metal resources, Arm machines, and kind of, take advantage of it as part of their CI/CD build, pipeline wasn't easy, right? Adoption took a little bit to kind of really get there. But if you recall, 2017, 2018, those are very, very early kind of days. And I think in kind of wide adoption for ARM, for kind of Arm ecosystem, especially in kind of container cloud native land. But luckily things kind of improved a little bit, and through this pilot that we've done recently with Actuated, Ampere, Equinix, kind of a little combined cloud native family here, our projects were really just looking for ways to, a couple things. If they were experimenting with ARM support, they were either hand rolling kind of their own, hosted, runners that they were running, who knows where. There's obviously some downsides with that approach. Some people were either, going the QMU hack approach to run these things, which is super slow, unfortunately. And, obviously there's, some security issues if you're kind of just using the hosted runners on GitHub and self-hosting yourself. So when this opportunity kind of came around to like, hey, we got a lot of great resources from Equinix and kind of Ampere machines over there, can we use them more efficiently, more securely, and just improve, let's call it the efficiency of the resources that we're using, right? Because cloud native, truly one of the kind of tenets of cloud native is optimizing efficiency of kind of resources that are dynamically available to you. And this was kind of a great opportunity for us to kind of do that. And even though it's still very early days, I'm kind of very excited to see the kind of success in early projects taking advantage, of this awesome resource. And I'll stop there talking about. We can maybe talk to Alex, who can maybe dive in a little bit more on kind of the details, since he's been doing a lot of the hand holding. But it's been very well received in the community, and these days ARM support is significantly better than it was a couple, even 2-3 years ago, because, in Kubernetes land, you'd be like, great, one of the CNIs I'm using, doesn't support things, and it's just gotten a lot better. So I'm just thrilled kind of how fast things are improving.
Thank you. Actually, you mentioned, and I mentioned in the intro as well, that running GitHub self-hosted runners on ARM64 poses some issues. Alex, can you talk very briefly about how Actuated addresses some of those issues and what they are in technical detail?
Yes. So if you look into GitHub's documentation, they say if you're running an open source project or repo, it's unsafe to use the self-hosted runner. And that is exactly what Etcetid had been doing for several years. And not only that, they had a team of 5 people at different fan companies that were maintainers that were on call for maintaining 2 servers in case something went wrong. And so that sort of shows you a little bit about what it's like. Now, there are obviously some ways of running it within Kubernetes, and the Cloud Native Computing Foundation would be the perfect place to run hosted runners in Kubernetes, but the same issues still are there. And they even get a little bit worse. And we see this from customers as well who've tried GitHub's Kubernetes operator. It's okay until the point you build or run a container. And then you need the privileges elevated so high that you can compromise every node and the entire cluster. And many people just put their head in the sand about it. And, that's what Actuated is about. Instead, micro VMs are used, which have their own Docker instance that's completely isolated, and they only exist for the lifetime of the build. And then they're completely destroyed. So that's the main difference.
Okay. And from a performance perspective, how does the micro VM approach compare to, say, a traditional GitHub hosted runner?
So that's one of the other things that our customers tend to turn to us for, is there is some limit. Either it's costing them too much on a per minute basis and they want flat rate billing. They're running out of disk space and they can have a custom size with our solution. Their CPUs aren't quick enough. So even the fastest AMD EPYC chips that are quite quick are not as fast as their Ryzen chips that you can get from some hosting providers. And when people switch, they can see a 2 to 3 times improvement. And so sometimes we don't want it to take 60 minutes. We want it to take 20 minutes to do a build to master. Right. And so that's another reason. So generally, it's very quick. We've seen really good performance. There is some overhead of using a micro VM, but mainly CI is about CPU speed and having enough RAM to fit your programs in than, like raw IO or things like that.
So Ed, can you describe a little bit how Equinix supports CNCF with the CNCF Infrastructure Lab and the open source program, but also like what has the impact of this pilot been on the infrastructure that you're making available to the CNCF?
Sure. Well, we've been supporting the CNCF Community Infrastructure Lab since its beginning. I got involved in 2017. Um, the initial commitment was small because we weren't really sure that anyone would use it. And as time went on, uh, it got to be more important, not just for the projects using it, but for us as being sort of the centerpiece of our open source efforts. There's about, I don't have the exact number, but on the order of about 50 projects in the CNCF using the infrastructure. Um, a mix of benchmarking and testing and performance characterization, performance improvements, lots of CI/CD as you've heard here. Some folks doing more experimental stuff, all running on the Equinix metal bare metal architecture. Um, what we don't have compared to some other cloud environments, we don't run any agents on these systems, so we don't know. We know how much bandwidth people are consuming, but we don't have really deep insight into their workloads. And one of the things that I'm really happy with this actuated pilot is really for the first time, from my perspective, getting some. I think that the current term for it is observability into instance needs. Um, how much memory does the project actually need? What are the disk characteristics? What are the compute characteristics? So really being able to better tailor the offering to the needs. Um,
And I think we've already seen some right sizing of workloads based on the feedback that we got from Actuated,
Yeah,
right?
so there was one workload. I don't remember, Alex, you might know better which one it was, but their initial allocation was a
Yeah.
32 gigabyte slice. And after profiling the workload, it was clear that that was an estimate that was off by nearly an order of magnitude, and it would easily fit in an 8 gigabyte slice, so with plenty of space left over for
I think the numbers were actually 2 gigabytes and 4.
2 gigabytes. Well, but we stuck them in 8, right? Because of
Yeah.
the just
You
to
know,
be
we
sure.
can with a server with 256 gigs of RAM, we can afford 8. Yeah, and we don't
Yeah.
want anything weird to happen. So GitHub had a minimum of 8, so we thought, yeah, that would be a safe minimum to offer.
Yeah. So I think, so much of software development is isolated from the hardware. People who are writing code kind of know in the abstract what it is that they're doing with the machines, but they might be a couple levels removed from the operational characteristics of it. And so getting that closer, the tighter coupling, I think, has been good. In terms of impact of this program on the overall setup, um, it's a little bit too early to say what the long term results are because there hasn't been a long term yet. But I would say that I would characterize it in a couple of real positive directions. One, we've been able to onboard some projects that had not previously been using ARM support into this because we have the capacity to do it now that we didn't have with dedicated systems. So we can slide another project in without requiring an additional unit of hardware. There's definitely the better result, as Alex described, of having an environment that's more secure and mitigated some of the risks involved in self-hosted runners. I always welcome additional people on the project who are smart and knowledgeable and know what they're doing and can help people in that initial onboarding effort because, as Alex noted, sometimes that takes a bit of work. Um, and it's one of these really weird situations. The usual trade-offs are better, faster, cheaper. Pick any two, and I think we've hit all three for this. So, like enjoy that win while you have it. I know that the resources are not infinite, and then if this were programmed to were to expand, it would take up more resources. But for the moment, it just looks like a win overall. So I'm super happy about it.
I'd actually like to take a tour of the projects that are benefiting. So I think we're talking about 8 projects here. Is that correct, Alex?
So the 8 are the initial pilot that CNCF and Ampere have sponsored.
And can we have a little walk through the projects, like what technology areas are they in?
At a very high level, I've just got some summary figures. So since the November, we've run 10,000 jobs on the ARM hardware on 2 separate servers. Right. And within that, that's 38,000 minutes of compute time. So that's for 7 projects. Now, not all 7 of them were onboarded on day one. Like one of them onboarded a week ago, one of them was 2 weeks before that. But those are Fluent. And Fluent was actually using the solution before the sponsor program came about. Etcetid is the biggest consumer of minutes actually in builds. Almost a half of that data comes from them. Containerd is the newest one to go on. Falco security. So think about eBPF, probes, some very important software there. Cilium for your networking. So it's actually more than 7 projects. So Tetragon and the eBPF Go library, they're both using it, and the maintainers are looking at what other repos they can add in. Now, if you think about lab requests, that might have been 3 servers from 3 different maintainers, or it might have been they each deployed 2. So maybe 6 servers have become a portion or slice of 1. Cryo is another one. And then there's a couple that are onboarded, but they just need a bit of time just to get in there and edit their builds, and that is Argo CD and OpenTelemetry.
And in general, what are the projects getting out of it? Are they getting just faster build time, or are they seeing improvement in their ARM64 support, or maybe a net new support for ARM64 that wasn't there before?
Yeah, so I would say with about 2/3 of these, it's ARM support that they didn't have before, or if they had it, they want to bring the tier up. So let's say tier 3 might be a community member pushes builds to their personal account. Tier 2 is their automated builds through CI using QEMU that are very slow and don't run on every commit. And maybe tier 1 is they run on every commit, every release is built through full ARM hardware, and there's perhaps some performance testing as well. And that's where an OpenTelemetry are very keen to get to with their work. Fluent have this. Etcetid, I'd say, would have that. And with Containerd, I think that they were just using QEMU and cross-compilation. So they're now running a new suite of tests that just weren't available before, just weren't executed.
Awesome. And I believe Argo CD are also going to be in that situation of previously ARM64 was run daily, and they didn't run the entire suite of integration tests, and they're going to be doing that across every commit from now on.
And to be honest, one other thing that the maintainers, I guess, at Falco are getting is they were running tests in Circle, they were running them on a self-hosted runner, they were running them through an EKS cluster, and they were running them through Prowl. And they were spending more money and having to come back to the pot and ask for more and more, and that's kind of awkward and difficult. And so now they're trying to consolidate a lot of that back down into what they're getting through Actuated.
So, Chris, if I can bring you back in here, it seems like there's been a very much a drive in recent times to improve the level of support of ARM64 as a platform, to bring it up to really equality and equity with x86. Have you seen the same trend? And if so, like, what do you see driving it? And how do you see that going forward in the future?
So yeah, I definitely see more ARM support for kind of cloud native applications, container support, especially in the CNCF ecosystem. And I think I look at it in the lens of 2 ways. Like first, if you kind of look at the overall industry, one, there's a lot more ARM available via cloud providers these days, outside of kind of the early pioneers. And just from kind of our experience, and if you kind of look at things, performance and price generally is amazing comparative to alternatives, right? You just have to ensure that you could run your stuff on the machine. So I think that's one kind of more of like a wider industry kind of trend pushing ARM adoption, out there. And, there's countless, posts on there from, companies like, oh, I switch myself to ARM, and all of a sudden our prices are down, whatever, 30, something percent, and things are faster. So like that's kind of been going on, and people are noticing. So that's kind of just a more of like a macro industry trend. From a little bit more of a CNCF perspective, like developers are I don't say like inherently lazy. They're just like they're busy, right? Like they have usually a lot of tasks going on, and if you could provide them something that somehow makes their lives a little bit easier, whether it's improved developer experience, improved performance on builds, so they're able to turn around changes faster. I think that's the other thing that is kind of driving adoption is just the, hey, if you're able to improve the speed of my kind of feedback loop, which is usually the CI CD pipeline, then developers are interested in that, and they just kind of have to know about it, and historically the experience to kind of get the ARM builds running was difficult, but now with folks out there like Alex with Actuated, there's a lot of different runners out there. There's just a lot more kind of support and improved developer experience for folks to kind of get started. So those are kind of my observations of you have the macro like industry. Hey, I need some cheaper, faster. Why not? Let's go take a look at it. And then from a developer experience, the tool chain has gotten a lot better. And if developers could get faster builds with minimal effort on their part, like why not, right? So
that was actually one of my favorite moments in this pilot so far has been when the etcd project, after committing one line to a GitHub runner file, GitHub action file, to use Actuated. Alex then was able to delete 60 lines out of the instructions on how to run ARM64 on ARM64 builds for etcd. That was pretty awesome. So the developer experience was great.
And I think we took 6 people off the hook as well for maintaining that.
So I think the developer experience has been a big selling point here.
And the service went back into the Equinix pool, right, as well.
And it built faster, I'm sure. So
And everyone depends on etcd whether they know it or not.
Yes, yeah, it's right down there at the bottom, and it's one of those projects that we were very proud to be able to help over the summer bring from tier 3 up to tier 1 support level by making sure that they were running their integrated testing more often.
No, it's awesome, and thank all y'all for kind of the collaboration. It's great to kind of see folks working across companies, geographies, borders, etc., and kind of improving the cloud native ecosystem for everyone.
And to what you said, Chris, I think I would add one thing, being opinionated for a second rather than just being the host, is that one of the things that's philosophically in the ARM ecosystem right now for the server chips is a lot of cores, a very high core density. Mm-hmm. And I think if you're talking about cloud native development, Alex alluded to it earlier, a big part of cloud native computing is increasing efficiency by right sizing workloads to what they need to run efficiently. And so I think the fact that you've got these processors out there with 128, 160 cores, 192 cores coming soon, and that you have the ability in a single socket to basically run a whole Kubernetes cluster. I think that's been really compelling as well.
One of my perspectives from the developer perspective is lots of developers are just not really used to the idea that they have 192 cores on tap, right? And that's just like the mindset is like, I've got a problem. It probably fits in 4 cores and 8 gigabytes. Like that's the size of the problems that I have. We've seen on other projects, not these, but other development efforts where in the past, people doing builds through QEMU where you were building a compiler or something like that, where the intermediate steps require large amounts of memory and very deep integration with the processor, and just like would not work in an emulated environment. So it's been a journey to get from the large numbers of slow cores that we had 6 years ago to the large numbers of fast cores that we have right now. But I do think it might take a number of years still for the typical developer to know what to do with a very large core count. Happily, Alex is not the typical developer. He's in a world where
Yeah.
he can divide an infinite number of cores into an infinite number of useful things.
Well, if you look at the data from this week alone, and this is mainly from Containerd being enabled, we used over 2 servers, 90 cores at peak. They were split 50-50 and 200 gigs of RAM. And so on our dashboard, we get to see the RAM going down in the chart. So it's available RAM. We see that dip down, and we see the correlation of what jobs are running in parallel for what repos, and then the load on the system. And so with those 2 servers, they were very nicely spread across, but we might have even got away with one for that peak period. In fact, when we had just one on there, we were struggling to get it up to 80 cores of usage because the builds are very sporadic as well. Somebody has a nightly build that runs at 9 a.m. UTC. Well, that's not really a nightly build to us, but it might be if you're in the Pacific Coast. And so as long as everybody is building at slightly different times, it all works out. But if everybody wanted to build everything they had all at the same time, then obviously we would back up a bit and burn that down.
So can I go around the table and get from each of you, what is the one thing about this pilot project that has most excited you, or that you've seen in the last month that you've kind of gone, wow, that's awesome. Let me start with Chris.
Yeah. So, I kind of alluded to this earlier. If you kind of look at the CNCF when it was founded, it has like a list of values, right? Being open, transparent, multi-platform, platform agnostic, et cetera. And this collaboration, across, companies, geographies really kind of speaks to that, supporting different, platforms and really I think gets us closer to that original vision of, CNCF projects being able to run on different architectures, different hardware, different providers, and so on. So I just love to see this type of thing and kind of, hopefully we continue to collaborate and improve ARM support across the whole CNCF ecosystem.
Yeah, I hope so. Let me go to Alex.
So I've been working with Equinix, Metal, and Ed back from 2014 when they saw that I was trying to build Docker on ARM, and they gave me access to big ARM servers at the time. And so for me, we've spent a lot of time in my team writing tutorials and guides to help projects adopt ARM. And so when we can see that improvement in speed and efficiency, or even just the ecosystem support, that's exciting to us. So we're enjoying seeing the platform used. Hopefully this initial success will potentially lead to a slightly larger pilot if there's appetite for that. And I guess the other thing is, we're glad to see the system working, get to work with really smart people. All the open source projects that we've had discussions with, I've learned a lot more about eBPF, for instance, when we had to enable that. So yeah, it's just great to work with really smart people.
Ed.
One of the things that's been most interesting about working with the CNCF, just like Alex mentioned, is just like the super high caliber of the people involved with things, and looking forward to the next year to 2024. I'm really hopeful that this will be the first of many collaboration efforts. The CNCF and the Linux Foundation have a number of organizations that are contributing resources to the project in general. And I met with some of the other folks who were doing this in Chicago at KubeCon, and I think there's room both to expand this collaboration and to identify other collaborations that could make the set of services available to CNCF projects, level up everyone in terms of what's available to them. So, and like Alex, I'm the eBPF stuff is like, oh, that's really interesting. We could learn a lot from that. So.
Yeah.
For example, on OpenFaaS, we had a customer that said we want to know if someone gives us a report from the police, what OpenFaaS function made a request to that abused server. And I was like, well, you should probably just use Cilium or Istio or something. And then we onboarded Falco. And I was like, oh, by the way, I heard this. And I said, look at this sample. I ran the program on my computer. It worked straight away. It gave me the pod IP address and everything. And so, yeah, just getting to see what the CNCF has in its estate, the various projects, how they apply. And to Dave Neary had said to me, we've got this list of 3-4 projects for you to help out. They all use eBPF, by the way. This is a technology that's very, very clever.
Yeah, you all stole my thunder because I was going to talk about the eBPF stuff and BTF. Yeah. And it's the range of projects that's been interesting to me as we go from everything from a lower level key value store like etcd and BoltDB all the way up to continuous integration, continuous delivery with Argo CD, and particularly Cilium and Tetragon is near and dear to my heart. I was working on networking for a very long time, and seeing the twin events of the eBPF documentary that came out over the week of KubeCon, which if any of you have not seen it, go look at it on YouTube. It's awesome. We'll put it in the show notes as well. And seeing that we can, this is something that's not possible inside containers, seeing that we can create custom kernels and custom eBPF probes for CNCF projects like Cilium and Falco and Tetragon, really drove home to me that this is a compelling project and a compelling technology. So thanks for putting it together, Alex. So thank you very much for joining me. And I want to thank Ed, Alex, Chris for all the time that you've given us over the past month and before and today, obviously. And thank you for joining us on the Ampere Developer Impact.
Thanks. Goodbye.
Awesome. Thank you.
Goodbye.